So you know when you try to run a video cable across your living room and the signal just randomly drops?
Oh, yeah. We've all been there.
Right, well imagine trying to send that same signal across like 5 football fields.
That is a completely different nightmare.
Exactly. And I was looking at a schematic the other day for a medical imaging suite, like an MRI room,
Hmm.
and it really hit me how much of a nightmare that environment is for AV integrators.
Oh, the magnetic fields.
Yeah, you have these massive magnetic fields that will just absolutely shred a video signal on a standard copper wire.
They really do. I mean, when you're dealing with industrial motors or medical magnets, copper basically turns into an antenna.
It just picks up everything.
All that electromagnetic noise.
Yeah.
Which completely destroys your signal integrity. And that is exactly why, for this deep dive, we were looking at something very specific from the HDTVSUPPLY catalog.
The Kramer 616RT.
Right. It is an infrastructure necessity for those environments, not just an accessory.
So our mission today is to figure out how this professional AV gear uses light to move massive amounts of data without any interference.
Because this system actually comes as a pair.
Yeah.
You have your transmitter, the 616T, and the receiver, the 617R.
And the transmitter takes a dual-link DVI signal and converts it
Purely into optical signal.
right into light.
Exactly. It uses what is called duplex multimode fiber optic cable with these LC connectors instead of standard copper wires.
Which, I mean, those LC connectors, for anyone who hasn't messed with fiber lately, those are the small click-in ones, right?
Yeah, and they are very secure.
Mm-hmm.
And by moving to this multimode fiber architecture, you effectively delete the whole concept of electromagnetic interference.
Because photons do not have a magnetic charge.
Right, so you can run this cable right next to an MRI machine or a generator, and the video signal is EMI and RFI free. It won't even blink.
And it can go far, too. The specs say up to 500 meters.
Which is about 1,640 feet.
That is wild. Pushing uncompressed video that far?
And not just any video. This supports resolutions up to WQUXGA at 33 Hz or standard 1080p at 60 Hz.
Wait, WQUXG8, that is 3,840 by 2,400 pixels.
It is a very tall 16.9 aspect ratio.
You do not see that on consumer TVs at all.
No, that screams specialized application. You need that extra vertical real estate in high-end medical imaging or complex industrial control interfaces.
To monitor vitals or factory outputs, you need every single pixel of that density to be sharp.
And fast. The maximum data rate here is 13.5 gigabits per second.
So that breaks down to about 2.25 GBPs per graphic channel.
Uncompressed, too. That is the beauty of fiber. You are not crunching the data down and losing quality just to squeeze it through a wire.
It is just a raw, clean pipe. And I noticed the safety specs mention it is laser class 1.
Which is crucial.
Yeah, because even though you are shooting lasers through glass, it is totally safe for general use.
You don't need a laser safety officer on site just to plug in a monitor.
Now, there is a specific caveat in the catalog that caught my eye. It explicitly says, not HDCP compliant.
Which sounds like a bad thing.
Right, for a home user, that means you cannot transmit copy-protected content like commercial movies or streaming services.
But for this audience, it is actually a vital feature.
Because HDCP is that digital handshake.
Exactly. And in a live event or a surgical feed, if that handshake fails, your screen goes black.
Which you absolutely cannot have.
No. Stripping that out ensures pure reliability. This device is strictly for professional computer interfaces and open content.
It really highlights the divide between consumer home theater gear and professional infrastructure.
The Kramer 614RT represents this massive shift from electrical to optical transmission for high-end displays.
It is the hidden infrastructure that you never think about, but it powers those massive screens we see in stadiums and control rooms.
It requires staggering engineering to get an image across a venue without a single artifact.
It really does, which leaves you with a provocative thought, honestly.
What is that?
Well, if fiber optics solve the distance and bandwidth and interference issues so perfectly, why are we still relying so heavily on copper cables for our short-range connections at home?
That is a great question to leave on.
Something for you to mull over next time you are wrestling with a thick HDMI cable behind your TV. Thanks for joining us on this deep dive.